Hi, I'm Cece.
And I'm Catherine.
And this is our extra credit project on the comparator hypothesis.
The concept of Q competition has been researched for many decades and has prompted the development of mathematical models of Pavlovian conditioning. The Rescorla-Wagner model, for example, is based on the discrepancy of expectation and explains the overshadowing process as a failure to associate the target conditioned stimulus with the unconditioned stimulus. The expression deficit models, on the other hand, state that the unconditioned stimulus is conditioned to all cues present during training, but that the strength of the association depends on contiguity. This is then manifested by the failure to express learned information at test. The comparator hypothesis, developed by Blaisdell, Bristol, Gunther, and Miller in 1998, is an expression deficit model. This model states that the amount of response in a conditioned stimulus is determined by the strength of the CS-US association relative to the strength of unconditioned stimuluses associated with other cues. In this diagram, we see that link 1, which is the CS-US association, is compared to link 2 and link 3, which are the CS comparator association and the comparator US association. If the CS-US association is stronger than the associations made with other cues, then excitatory learning will take place. This shows the comparator hypothesis as applied to latent inhibition. This shows the comparator hypothesis as applied to the overshadowing process. And this shows the comparator hypothesis applied to both latent inhibition and overshadowing.
Okay, so now we're going to talk about the experiments. All experiments were conducted by measuring the conditioned suppression of drinking in thirsty rats. Experiment 1 was designed to investigate interactions between latent inhibition training and overshadowing training. The researchers are expecting 3 things. 1, pre-exposure to stimulus X alone will lead to latent inhibition of learning about X. We are already pretty familiar with this concept. 2, presenting A and X simultaneously before a US will lead to overshadowing. This is also pretty familiar. But the researchers are also predicting a third very counterintuitive point. According to the comparator hypothesis, they believe that pre-exposure followed by overshadowing will lead to more conditioned responding. So here's the experiment. The first group is the experimental group, the one we're really focusing on. This is the group that had latent inhibition training followed by overshadowing training. Just so you know, X was a tone, A was a light, and the US was a foot shock. Y was a different kind of noise. So in phase 1, the experimental group gets pre-exposure to the tone. In the second phase, they get blocking of the tone and the light, followed by the foot shock. In these first 2 control groups, one group just undergoes latent inhibition and the other just undergoes overshadowing. The acquisition control group was expected to show high condition responding to the tone, since these rats didn't undergo either pre-exposure or overshadowing. The last control group served to make sure the results weren't caused by a generalization decrement. So now you know the setup, here are the results. As expected, the groups undergoing latent inhibition and overshadowing didn't learn about the shock very well. But the experimental group that underwent latent inhibition and overshadowing showed just as much, if not more, fear to the tone as the regular acquisition group. This supports the researchers' hypothesis that, rather than summating, the 2 trials counteracted each other. This result is counterintuitive to the Pavlovian conditioning models that state that learning is behavioral.
As we see in this table, phase 1 of experiment 2 consisted of pre-exposure in context 1. All rats were exposed to either the target stimulus X, the tone, or an alternate stimulus Y, the white noise. In phase 2, overshadowing took place for groups latent inhibition and overshadowing, as well as the overshadowing group. They were presented, as in experiment 1, to the compound stimulus AX, the light, and the tone. However, following the AX presentation, the rats were exposed to stimulus B, a clicker. All other groups received only the tone, followed by the clicker. In phase 3, all rats were transported and handled as to match the events that occurred surrounding the training phases. In phase 4, all rats received presentations of stimulus B, the clicker, followed by the unconditioned stimulus, a foot shock, in context 2. At test, the generalization decrement group received the AX compound stimulus, while all other rats were presented with the tone, stimulus X. The results of this experiment replicated those of experiment 1. It was found also that the training given to the latent inhibition and overshadowing group led to a strong conditioned response to the target conditioned stimulus, the tone. In the separate latent inhibition and overshadowing groups, however, the pre-exposure overshadowing effect decreased responding.
Experiment 3 sought to further the findings of Experiment 2. Specifically, the researchers wanted to determine whether the primary comparator stimulus for X was the context in which X was learned, or whether it was stimulus A. In other words, were the rats in the experimental group predicting the foot shock because they learned to connect the tone with the context of the shock? Or because they learned to connect the tone with the light that also predicted the shock? The researchers tested this by either inflating the context or the secondary associations made with stimulus A. Here's what it looks like all written out. This time, there were 3 groups getting latent inhibition and overshadowing training. One of these groups, N, didn't get inflation at all. Another group got inflation of stimulus A, or the relationship between A and B was strongly emphasized. The third group got inflation of the experimental context, or the experimental context was strongly emphasized. As in the previous experiments, control groups of just latent inhibition, just overshadowing, and just acquisition were also conducted. The results were as follows. The inflation of stimulus A had no significant effect on conditioned responding to X. However, inflation of the context resulted in significantly less conditioned responding to the tone. The rats in this group took less time to drink, exhibiting less fear to the presentation of the tone. This indicates that it is in fact the training context that serves as the comparator stimulus for stimulus X. When the rats hear the tone, they compare it, so to speak, with the mental representation of the context in which fear learning occurred to determine if they should be scared or not.
As we see in this table, phase 1 of experiment 4 consisted of pre-exposure. All rats were again exposed to either the target stimulus X, the tone, or to an alternate stimulus Y, the white noise, in context 1. All rats were also exposed to context 2, but with no stimulus presentation. In phase 2, half the rats received overshadowing in context 1 and exposure to context 2 with no stimulus presentation. The other half of the rats were exposed to context 1 with no stimulus presentation and received overshadowing in context 2. All rats were exposed to context 3 with no stimulus presentation after phase 2. At test, all rats were tested to the target stimulus, the tone, in context 3. The results of this experiment showed that the training received in the same context led to a strong conditioned response to the target conditioned stimulus, the tone, when tested in context 3. In the cases of rats that received training in both contexts, the conditioned response decreased when tested in context 3.
So, we can conclude, based on the results of experiment 1, that latent inhibition paired with overshadowing attenuates the results of either treatment alone. Instead, strong conditioned responding can be observed. Experiments 2 and 3 support that this effect was a product of changing the primary comparator stimulus for the target response. Experiment 4 illustrates that this effect is context-specific to the environment where X was originally learned. Put together, these experiments are excellent support for the comparator hypothesis described at the beginning of this video. There are two possible explanations for the selection of particular comparator stimuli. One possible reason is the existence of higher-order comparator processing. Each comparator stimulus has its own set of comparator stimuli that control how effective it is as a comparator stimulus for a particular event. The presence of different comparator stimuli may improve or degrade the effectiveness of a particular comparator based on the discrete event and environment in which it is acting. In other words, different comparators are beneficial for different circumstances. Another possible reason is comparator interference. Instead of modulating each other, as in the theory of higher-order comparator processing, this concept theorizes that comparators actively compete for associative strength. If this is the case, the effectiveness of the primary comparator would be reduced due to conflicting modulation. In other words, comparators are constantly fighting it out, and only one can win each time. Regardless of the reasoning behind the effectiveness of different comparators, these experiments illustrate a phenomenon unpredicted by other models of learning. They indicate the success of the comparator hypothesis. According to this data, pre-training may play an important role in the development of learning that occurs later down the road. Thank you!